Alright, so today we will be talking about covalent compounds and how to write those. We talked about ionic compounds and how we write those on Tuesday or Wednesday, depending on which class you are in. So now we are going to talk about how do we write on the covalent side. We're talking about how do we write those chemical formulas. So covalent is a little bit different since we don't do the crisscross method with our subscripts. We do something a little bit different called prefixes to determine how many atoms are in a particular formula. So let's start with some common prefixes that you may have heard before. I'm sure you've heard the word tricycle. And how many wheels does a tricycle have? 3. Right, because of that prefix tri. All right, we just had our 2020 just came to a close, and that was what we call the start of a new decade. And a decade lasts 10 years. That prefix deca means 10, so decade is 10 years. You know about the cute little, really smart ocean creature called an octopus. An octopus has 8 legs or arms. That prefix octo, actually means 8. All right, and maybe something you haven't heard of is a heptathon. So that is an event with seven separate events. Maybe you've heard of a triathlon, having 3 events: biking, swimming, and running. And a heptathon actually has 7 events instead of 3. How do we know this? This is stuff from past experiences. So we use these prefixes in real life. All right, and we have the prefix list here. So mono means 1, di means 2, tri is 3, tetra is 4, penta is 5. You've heard of a pentagram. Hexa is 6, like a hexagram or a hexagon. Those are what the bees make, their hexagon shape in their honeycomb. Hepta is 7. Those two are easy to mix up. So hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. For our Spanish speakers, nona might be a little bit easier to remember, as nuevo is 9, nona is 9. Maybe that's the way you can remember it if you speak Spanish. All right, so what we're going to do here is we're going to, when we're trying to come up with these formulas, when we are given the chemical name, we're going to break it apart. So here I have carbon. We know what carbon is. That's just all by itself. So we know that the chemical symbol for carbon is a C. So now we have another word that maybe you're not familiar with, monoxide. So we're going to break it apart right here. Mono, they dropped that second O, is 1. I'm going to write a 1 down here. And oxide, if we look at our prefix or our formula sheet, here we can find oxide is O. So what is oxygen? And we dropped the gin and we added an ide. So this is O. So now that we have all that information, we can write CO. The funny thing about chemical formulas is that 1 is implied. So when you are writing a formula, don't write the 1s, drop the 1s. 1 is implied, only cool people don't write the 1s. So be cool and don't write your 1s. Like in math, when you say x, we don't usually use 1x. We just have that. That is implied. It is the same thing in chemistry. All right, let's move on to our next one. We have carbon again. We know that is C. And with covalent compounds, the first element in the name, if there's only one of them, it will drop the mono. So we don't say monocarbon monoxide, we just say carbon monoxide. Again, that one is implied, but in the second element in the name, it is listed there. So in the first one, we don't use a prefix if there's only one, and then the second one we do. You won't be responsible for naming these, we're just gonna pull the formulas out of the name. All right, so now we have di, and if we look up here, we know di means 2, and oxide again is O. So here we have something that you're probably familiar with is CO2. Notice how I did not write a 1 under carbon, even though we know that there's a 1 there. All right, we got carbon again. Now we have a different prefix, tetra. I look up here, tetra is 4. And then I have fluoride. So if I get rid of the "ide," I have fluor. Oh, I know an element that's fluor. Fluorine. Yes, that is fluorine. It is also listed on your formula sheet. I don't expect you to have all of these memorized. Fluorine. Fluoride should be on here. Fluoride right here. So this is F. So we have 1 carbon. Remember, if you're cool, you don't write the 1. And we have 4 fluorines. So carbon tetrafluoride. All right, we're gonna do the next one. Iodine. We know that one, that's symbol I. And then monobromine. Mono meaning 1. Oh, I changed colors on you, sorry. And then bromide, sounds like bromine, bromide, so that's BR. So I, BR, and we don't write the 1. I don't know if anyone has ever heard the expression mano a mano. Maybe not. Anyway, that means 1-on-1. If you've heard that expression, maybe you'll be able to remember mono meaning 1. All right, so now we actually have a prefix on our first element. Here we have a di. Di meaning 2. Think of a pair of dice. Di meaning 2. Phosphorus is P. Penta. When there's oxygen, usually we drop that last vowel. So pento is 5, and oxide again is O. So P2O5. All right, we have our next one, which is nitrogen. All right, no prefix, so that means we have a 1 here. Nitrogen symbol being N. Tri meaning 3, like a tricycle, and O for oxygen. So we have nitrogen, and that 1 is implied, O3, nitrogen trioxide. All right, we have another prefix here, di, 2 sulfurs, deca being 10, and then fluoride again is F. S2F10, that is a lot of fluorine. That is a lot of fluorine in one compound. All right, here we have a prefix, tetra meaning 4, phosphorus is P, octooxide, octo like an octopus is 8, and oxide is O again. So we have P4O8. All right, we got 3 more left. So penta is 5, like the pentagram is a 5-sided shape. The pentagram in Washington, D.C. has 5 sides. Boron, symbol B. Nana, 9, and chloride, symbol Cl. So B5Cl9. Pentaboron nanochloride. These start to become a mouthful when you get like more and more prefixes and elements. All right, di we said is 2N, tri is 3S. So dinitrogen trisulfide is written as N2S3. So iodine is I, and then hepta is 7, and bromide is Br, so IBr7. And that's all there is to it. Remember, when you are bringing things over, the first compound, the first element in the name should be the first element in your formula. Don't switch them around, just keep them as they are in the name. All right, let's switch over to the back side here. We're going to write down some of the steps we have for writing these formulas. So number 1, you're going to separate the prefix from the element name. Remember, that's what we did. We looked at how many prefixes we have, how many elements we have, and we're just going to separate them out. So next you're going to determine the element symbol from the name. So remember, if we had something like oxide, we have to look and actually see what is our chemical symbol. Oxide would be O, bromide would be Br. Number 3, you're going to determine the subscript from the prefix. So we're going to look at our suffixes, or I'm sorry, we're going to look at our prefix and we're going to determine what suffix, let's start that again. We're going to look at our prefixes and we're going to determine what subscripts we need. How many of each element is this chemical name telling us we need in our formula? All right, and then our last step is write it all together. All right, I'm going to add a little star here. Remember, ones are implied. So don't write your ones. Cool people don't write their ones. All right, so now I'm going to have you do these 4, and I will post the answers to BB9. Last thing that we are going to do, since we've talked about ionic now and covalent, we're going to make a little chart since we have room at the bottom here, and talk about what are the differences when we're naming these. So ionic, covalent. All right, so when we are actually naming these, remember ionic is a metal and a non-metal. Or as we start to get into our polyatomic ions, like these guys over here, they are a cation plus an anion. Okay? So we can use the example sodium chloride, table salt. This is our metal, and this is our non-metal. So when you are trying to determine if it's a ionic or covalent compound, you're gonna have to go back to your roots from last unit and remember and look at it and be like, okay, is this a metal or a non-metal? Check your periodic table, use the step method to determine if if it's a metal or a non-metal, and then you can follow those rules to name them. All right. So, in our ionic compounds, we have cation comes first in our formula, and the anion is second. In our ionic compounds, the net charge is 0. And we're going to use the crisscross method. All right, let's use an example. We're going to use BeP. So this is a +2 and P is a +3. Use the crisscross method, so this 3 comes down here, this 2 comes down here, 3, 2, and we're going to rewrite it BE3, P2, and those are our new subscripts. So that is how we write our ionic compounds. On the flip side, for our covalent compounds, this is a non-metal plus a non-metal. We're going to use the example carbon dioxide. So the easiest way to determine is this a covalent compound or a non-covalent compound is when you have prefixes. Prefix, covalent. Okay, that is the easiest way to determine if it's covalent or ionic. If there's a prefix, you are looking at a covalent compound and you're going to use your rules from above. I apologize for the noise with our class next to us. They're doing an experiment. All right, so we're going to use, for our example, carbon dioxide. All right, di meaning 2. There is no prefix here, so we're going to use a 1. This is C for carbon. Oxygen is our oxide. We're going to write CO2. Little note down here, 1s are implied. Same over here. 1s are implied. We do not write our 1s in our formulas. All right, that's all I have for you today. I hope you have a great rest of your day, and tune in for our next set of notes.